Hello students, in this video you will understand the concept of isomerism. As far as isomers are concerned, these are the compounds having same molecular formula but different structures, and hence they have different physical and chemical properties, and the corresponding phenomenon is called as isomerism, right? This isomerism can be broadly classified as structural isomerism and stereoisomerism, which are further subdivided into various types as on your screen, right. So, we will consider it one by one in detail. Let us consider the first isomerism, that is ionization isomerism. So, the ionization isomerism exists due to interchange of groups within or outside the coordination spheres. So, as you can see in the quoted example, Pr is in the coordination sphere in the first isomer, whereas in the second isomer bromine is outside, right, outside the coordination sphere, and sulfate is interchange the position here, right. So, such will be called as ionization isomers. One more thing to mention about them is these isomers have same molecular formula, but they have tendency to give different ions in solution. So, definitely in presence of solution, within the solution, this will be one ion here, one complex ion, and the other will be the sulfate ions. So, you will get a positive test for sulfate ions for this particular isomer, and you will get a positive test for bromide ions in this particular isomer, since this would be a complex ion. Is it clear? Then move on to the second type of isomerism, that is hydrate isomerism. In case of hydrate isomerism, as the name suggests, here water has an important role to play. Now, water can be in any way, it can be inside or outside the coordination sphere. If it is inside the coordination sphere, then we will say it is acting as a coordinated group. If it is outside the coordination sphere, it is acting as a water of hydration, okay, and such isomers will be called as hydrate isomers. Take an example of chromium complexes. So, here 6 water molecules inside the coordination sphere as a coordinated group, 5 inside, 1 outside. So, 1 outside is acting as in water of hydration. Here 2 molecules of water of hydration in the third isomer and 4 molecules inside the coordination sphere. Okay. So, that is about the second type of isomerism called as hydrate isomerism. Next type is the coordination isomerism. This isomerism occurs in compounds which have both cationic and anionic complexes, and this particularly happens because of different distribution of the ligands. So, as the example quoted on your screen, one of the complex, say copper, is an cationic complex and the other is an anionic complex ion, then in that case there is a different distribution of ligand. As you can observe, in the first isomer you have 4 amine ligands coordinated with the central copper, and in the second case you have 4 chlorine ligands coordinated with the copper ion. Similarly, platinum is coordinated with 4 chloro ligands, and in the other isomer it is coordinated with 4 amine ligands, right. So, that is about coordination isomerism. One more thing you can make a note in case of coordination isomerism is, it is not necessary that always the metal ion is different in both the cationic and anionic complexes. This can be the same, right. Say for example, here copper, as well as in the other complex ion there is a metal ion, the same metal ion, that is copper again. So, this can also be the probability, right. So, that is about coordination isomerism. After that, the fourth type is linkage isomerism. As the name suggests, we are talking about ambidented ligands here. What are ambidented ligands? Ligands having more than one donor sites. Say for example, if you consider nitro group. So, nitro group, a nitro ligand is an ambidented ligand, because in the form of a nitro group it can coordinate through this nitrogen atom. Similarly, it can coordinate through O of nitro group, which is called as a nitrito group now, and here it can coordinate through oxygen atom. Okay. So, such ligands are playing a main role within this linkage isomerism. Take an example. The first example, so cobalt isomer, which is yellow in color, and the other isomer of it is red in color, The only difference you can observe in both the isomers is, in one case NO2 group is in nitro form and in the other case NO2 group is in nitrito form. Is it okay? So that's about linkage isomerism. Let us move ahead. The fifth type is coordination position isomerism. This type of isomerism is exhibited by bridged complexes and it results due to different placements or attachment of ligands. For example, as you can see, both the isomers, they are bridged, right? So these are the hydroxyl bridges present here. After that, what we are saying, they have different distribution or different attachment of ligands. So as we can observe here, NH3 4 plus 2, so total 6 amine ligands and 2 chloroligands. In the other isomer of it, again we have 6 amine ligands and 2 chloroligands, but the attachment or the placement of ligands across the bridges is different. Okay, so that is the concept of coordination position isomerism. The next type of isomerism is polymerization isomerism. Now this isomerism is not a true isomerism because the compounds in this case or the isomers representing this concept have the same empirical formula, but they have different molecular formula. Consider an example quoted on the screen. So I am taking a cobalt complex and the corresponding polymerization isomers. You can observe here, this is one kind of polymerization isomer and this is another isomer of it, right? However, both of them have same empirical formula, but what about the molecular weights? They are completely different, right? So such will be called as polymerization isomers. After that, the next category is for stereoisomers that I would be covering in the next series of this video. Okay, so be updated, work hard, stay safe.